Detention.
Okay, and that's it? Yeah, okay. As you're doing your do now, we do have a couple of visitors today. I think my professor was in here before, right? At the beginning of the year? Yeah, he just remembers. He is videoing. No one, don't worry, we're not going to show the world the video. I'm going to watch it. A couple of other teachers will watch it so that we can become better teachers for you. Okay? You have one more minute. You do have it. Check your notes. Check your reading guide. Good. Good. I'll take that. Good. You're done, Ethan? Are you done? Yeah, go ahead. Good. I'll take it. Good. Capital T with a period. Right. Perfect. I'll take it, but I need a capital T. Good. Good. Got it. Good. You're gonna solve it. Good. Good. What? No. Kind of, but that's fine. Alright. I got everyone's do now? Alright. Good afternoon. Happy Monday, everyone. We are starting off today with a puzzle of the continents. So, I have enough for partners, for you to work with partners. You can see, like, so you will have this paper. This is the Earth. The circle is representing the Earth. And your job is to piece together the continents how you think they fit together. Alright, so I'm going to give you a few minutes with your partners to work on these puzzles. And who's my paper manager this week? Krista, can you see? Ashley, will you help me pass these out, Ashley? As soon as you get your puzzle, you can start working. Myron, I can. Be careful with the pieces because I want to use these with my homeroom also. You can go. Do more. Or one more. Yeah, we take those back. You take them to the back. Alright, cool. You do not have to do it silently. You may talk to each other. Okay, you are doing your puzzle. 2 people. Yeah. No. No, oh, not my homeroom. Like my classes at ASU. Alright, actually over here. I didn't realize that. You can work on one also. Ricardo, Hazel, and then Arturo Cameron. If you think you have it put together correctly, raise your hand. I'll check it. No, that's not right. You're trying to see how they fit all together. You're not making the earth as it currently is. Oh.
So we're gonna write the first one.
No, not the earth, how it currently is. How these fit together. Like that or something. Good. There you go. Okay. How could they fit together? Not how the earth currently is. It's not what the earth is like now. If these were all one and a half. Yeah. Good. There you go. You're missing some pieces. You need to use all the pieces. These are out here. No, not quite. That's pretty good. No. But no. We're gonna take 1 more minute. How would they put all together? All of them together? Good? How? Right?
I know. Now it's becoming
You think you have it? Whoa. Not quite though. Not quite.
Who has it already?
Alright.
No.
I'm gonna put the answer key up here for you to see.
Oh my God.
Go ahead and put your pieces like this.
They separate.
Yeah, you just have to push them together. That's what I was doing. I know I had that right. Smartness does not count.
Alright, tracking me and silent. 3, 2, 1. Thank you, Julia. Thank you, Dulce. you can see at the top of the paper with your circle on it, that is the world, they have the continents labeled as they are today, right? So number 1 is Europe and Asia. 2 is North America, that's where we are, right? 3, South America. 4 is Africa. 5 is India. And 6 is Antarctica. And 7 is Australia. Okay? However, this is not what the world looks like today, right? No. Okay? This was what the world looked like 200 million years ago. When all of these land masses were together, you can see that there's common animals found on different continents. Okay? You can see that both of these animals are found, or fossils were found, on 2 different continents because they were once together. They were once together. This supercontinent is what we call Pangaea. Yeah, this way?
You're missing part 6.
You're missing number 6. Let me get you one.
Oh, no, never mind.
You got it?
Never mind.
You thought it was 9?
Yeah.
Okay. All right. Cool. Let's read more about this in your textbook on page 14. You can put your puzzles toward the middle of your table. Leave that there. Page 14, please. Page 14, you don't need to write anything right now, but I would like you to be tracking your book, following along. This is page 14. Page 14, gentlemen. All right, it says, in blue, continents join together and split apart. The idea that Earth's surface might be moving is not new. As far back as the 1500s, when map makers started including North and South America in their world maps, they noticed something curious. The western coast of Africa and the eastern coast of South America seemed to fit together like pieces in a puzzle, like the puzzle we just put together. Were these continents joined at one time? And you can see on page 15 where it has South America and Africa in that picture. Would somebody like to read our second paragraph? Krista, go ahead.
In the late 1800s, German scientist Alfred Wegener
That's fine, go ahead.
studying this question. In 1912, he proposed a hypothesis known as continental drift. According to Wegener's hypothesis, Earth's continents were once joined in a single landmass and gradually moved or drifted apart. For many years, people did not accept Wegener's idea. Until the mid-1900s, did scientists find new evidence that made them consider continental drift more seriously.
Awesome. So he proposed this theory of continental drift, that our continents are moving. We talked about this last week. Who remembers what makes tectonic plates move? What makes tectonic plates move, Angelica? Julio, do you remember what it's called?
Convection currents?
Yeah.
Perfect. Convection currents, right? We have the convection currents going on in the mantle, so our lithosphere, our tectonic plates are moving, right, from last week. There's evidence, on page 15, there's evidence for continental drift, which we're actually going to read a little bit later, but I do want you to turn to page 16. 16, please. It says Pangaea and continental drift, because this is what we just created with our puzzles. For Wegener, all the evidence pointed to a single conclusion. The continents had once been joined in a supercontinent he called Pangaea. Pangaea comes from the Greek word meaning all lands. This giant continent reached from pole to pole and was centered over the area where Africa lies today. Will someone read the second paragraph? Vanessa, go ahead.
Pangea began to split apart some 200 million years ago. In time, the continents moved to where they are today. Yet,
Wagner?
Wagner could not explain how the continents moved because of his
Critics, good.
critics called continental
Yeah?
drift a fairy tale and rejected his hypothesis.
Thank you. So, people didn't believe him because they said, how could a continent be moving, right? They didn't believe him. You can see how his hypothesis, I guess how he viewed the continents moving in that chart on page 16, those pictures. Number 1 says 200 million years ago. The second picture is 180 million years ago. 3 is 65 million years ago. And then 4 is what the Earth looks like at the present time. Questions? No? Okay. You can set your textbooks aside for just a minute. And I don't know who my light manager is this week. Krista? Alright, can you hit the lights for us? We have a short video about Alfred.
Don't you just love it when you're right? Of course you do. And so do scientists, though the scientific method makes us have to pretend like we aren't. Fact is, the whole of scientific history is filled with people who were totally right, and everybody thought they were wrong. And today I want to tell you about one of those people. He changed the way that we look at the Earth. Alfred Wegener was born in 1880 in Germany. He was one of those rare people that's just good at and interested in a lot of different things. He got his degree in astronomy, but went into the relatively young field of meteorology, where he pioneered the use of balloons to track air currents and went on expeditions to Greenland to study polar weather, at which he was totally badass. He spent winters in a hut drilling ice cores, and he also made the longest crossing of Greenland's ice cap on foot for the win. But he was also interested in other stuff, including geophysics, which is why he got totally obsessed with this. He couldn't help but notice, like some school children will, that Africa and South America almost look like puzzle pieces. Sure, they're thousands of miles apart, but they really look like they fit together. Of course, other people picked up on this, like I said, you probably did around 4th grade. But another one of Wegener's great qualities is that he wasn't afraid to ask the stupid-sounding questions. So he just started asking people, continents moving, is that a thing? And if it was a thing, how would we know that it was a thing? And because he was a voraciously curious guy, he was looking for the answers to those questions in all kinds of places, and guess what? He found out that fossils of the same plant species had been found on both sides of the Atlantic. He discovered that the geology of the Appalachians was almost identical to that of the Scottish Highlands, and he learned that distinctive rock strata found in South Africa were the same as in parts of Brazil, almost as if the continents, I don't know, drifted. Finally, in 1914, while laid up in a military hospital bed during World War I, he pieced together his theory that all of the land masses on Earth used to be part of a single continent called the Ur-continent, or the origin of all continents. And over time, the masses moved, scattering fossils and rock patterns around the world. The next year, he published his research in a book, The Origin of Continents and Oceans. And the scientific community responded. They totally freaked out on him. Geologists dismissed him as a glorified weatherman. They held entire conferences devoted to debunking his book. Even his father-in-law, who was the most prestigious meteorologist in Germany, told him he should have probably stuck to the balloon thing. The conventional wisdom at the time was that continents used to be connected by land bridges, that later collapsed or were covered by the oceans, and that's how they explain stuff like matching plant fossils. Of course, Wegener didn't do himself any favors by being actually pretty wrong about a lot of stuff. Like, he could not explain, he had no idea how the continents actually drifted. He thought they were just plowing through the Earth's crust like an icebreaker. He also suggested that the centrifugal force of the Earth's rotation was causing the continents to drift, which is just totally kind of crazy. Yeah, so the damage had been done, and everybody in Germany thought he was a total crazy person. No one would hire him to teach anywhere. The only job he could get was as a meteorology professor in Austria. And that is where he was in 1930, where he decided he wanted to go back to Greenland to set up some weather stations. And during a weeks-long excursion to bring supplies to one of these remote stations, Alfred Wegener disappeared in a blizzard. His body was found the following spring, and it is still there today, buried in the ice. I know, right? Because he was right. I mean, not about everything, but about a lot of stuff. And at the time of his death, people were just starting to understand what the floor of the ocean actually looked like. And decades later, that research showed that there were giant rifts in mountain ranges under the oceans. And those were the boundaries where continental plates were pulling away from each other or crashing against each other. It wasn't until the 1960s that plate tectonics became something widely accepted by the scientific community. Though he wasn't vindicated during his lifetime, he is now respected as one of the greatest scientists of his era, and you can pay your respects to him through one of the many things in science that are now named after him, including the Alfred Wegener Institute for Polar and Marine Research, or the Wegener Peninsula of Greenland where he died, or craters on both the Moon and Mars. So, thanks here, Dr. Wegener. All of these fascinating things and more we bring to you from SciShow, where you can subscribe at youtube.com/sci.
Tell your partner one thing you learned.
That they laughed at him and they thought he was crazy. But he was right. Was right. They thought he was crazy.
Okay, do you have questions about the reading, about the video? He proposed this theory that the continents are moving. They used to be together, and then they moved apart. Okay? Let's write some of this information down. You should have picked up a piece of paper on your way in. If not, take one out. Today is October 21st, so we're talking about continental drift. So, as we read in our textbook, and we saw in our video, continental drift. Oh, sorry. Let me get that. Continental drift is the hypothesis that Earth's continents move on their surface, right? So they're drifting. The continents, the land masses are moving on the Earth. He proposed this as a hypothesis, right? A theory. He didn't know how they were moving. He didn't have all the evidence that we have today about the continents having been one thing. I'll answer that phone. Hello? Hey. Yeah, sure. And what we created in our puzzle was Pangaea, which is the supercontinent that included all of the land masses on Earth 200 million years ago. Just like a puzzle. Like they said, he noticed South America and Africa, they look like they fit together like a puzzle. Well, at one time, they were together 200 million years ago. These are 2 of your key vocabulary words for this unit. They are on our word wall. You will need to know them. We're going to have a test next week. And Julio, what were you going to say earlier? What causes tectonic plates to move?
Convection, right?
Perfect. That's what we talked about last week. Convection currents. Right? Alfred didn't know this, but we know this now. Convection currents in the mantle, the movement of the mantle, cause tectonic plates to move. These tectonic plates moving cause our continents to drift apart. Questions? Who has questions? No one? Perfectly clear? You understand everything? Makes sense? Okay, Crystal, you turn the lights back on? With your partner, decide who is Hot Cheetos and who is Takis. 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 In your own words, I'll be your partner, Arthur. In your own words, Takis, tell your partner what Pangaea is. In your own words, go.
Pangaea is when there was a whole group of the continents and they were all together.
Oh, remember who's Takis?
It was meant to only million years ago.
Hot Cheetos. Hot Cheetos. In your own words, tell your partner what continental drift is. Hot Cheetos, what is continental drift?
The continents got split up.
Did you say it?
No, I said it first.
Hot Cheetos. What's continental
Oh,
drift?
messed up in the first one. I'll show you.
Good. Okay, actually, pass this up for me.
And they were
Go ahead and open your textbook back up to page 14 again. 14 again.
That's why we did this outside. I'm writing.
And Ashley is passing out a paper for you. Want to take your puzzles so we don't lose our pieces?
He said Alex. He said Alex. It sounds terrible.
Well, make sure you have this.
Alex.
Did you not take my
I
notes?
said guy.
You're just reviewing them? So they're ready for my class when they come in. And you may take out your exit ticket. Finish up all your writing, stack up the books, please. And you may take out your exit ticket. Today, and complete sentences. What is continental drift? What is Pangea? Ideally, in your own words. Remember, we practiced that last week. In your own words. Go ahead and do your exit ticket. I'll check it in a couple minutes. In your notes from today? Good. Take one more minute. Seconds. Finished? Cool. In your own words. Love it. Good. Good. Well, will you take that puzzle up to the front or something? Good. Good. In your own words. Go like that. Good. Good. Good.
on your sleeve. Right there.
Okay. That's it. We will continue this tomorrow. So, Captain America, see you tomorrow. Spider-Man, Thor, Iron Man. See you tomorrow. Have a good day.